Hello friends, welcome to the channel Mind Your Math. Here I have presented you a problem from IIT JEE exam. Let n1 less than n2 less than n3 less than n4 and n5 be some positive integers such that their sum is equal to 20. Then find the number of such distinct arrangements of n1, n2, n3, n4 and n5. Pause this video, try to solve this question and see whether you are able to solve this or not. Let's try this question. So the question here says you have some positive integers n1, n2, n3, n4, n5 which are in increasing order, and their sum should be equal to 20. So how many such different arrangement of n1, n2, n3, n4 and n5 is possible? On the face of it, this question looks very clumsy because it seems that it is very difficult to write all the possible combinations of n1, n2 and n5 so that the sum is 20. But if you think a little bit about the same problem, we have n1, n2, n3, n4, n5 in ascending order. So can we reduce this equation to a smaller value? For this, let's write given n1, n2, n3, n4, n5 are in increasing order. So first thing, can we say n1 will definitely be greater than equal to 1, n2 will definitely be greater than equal to 2, n3 greater than equal to 3, so on. So on, can we say these things, right? Because n1 has to be least, so it has to be greater than or equal to 1, right? And so on. Now from this you can see we have n1 minus 1 greater than equal to 0, n2 minus 2 greater than equal to 0, n3 minus 3, so this is the equation. These are the conditions we have. Now this equation you can see can be written as n1 minus 1 plus n2 minus 2 plus n3 minus 3 n4 minus 4 and n5 minus 5 is equal to, just adjusting this, we will get this is equal to 5. Okay, this because this sum is, you can say 9, 3, 12 and 3, 15. Okay, so this equation we have got this equation. Now why we have written like this? Because now you can see if this variable is, let's say, x1, this is x2, this is x3 and so on, can we say now we have effectively an equation x1 plus x2, x3, x4, x5 is equal to 5. And here can we say x1 will be less than or equal to x2, less than equal to x3, x4 and x5? Yes, and all these values will definitely be greater than 0. Can we say this? Now why we have written all these values are greater than equal to 0, that is from this condition. And why we have taken them in increasing order? Because this n1 should be greater than should be less than n2 and so on. Now understand this, why we have taken equality sign here. Let's say if you compare x1 and x2, we have written greater than equal to. This is easy to understand why we have taken this less than, but why we have taken equal to sign also? Because even if x1 and x2 are equal, even if x1 and x2 are equal, we can say x1 plus 1 is equal to n1 and x2 plus 2 is equal to n2. So even if x1 and x2 are equal, this will make sure that n1 is less than n2. So that is why we have taken equality sign in each case. Okay. So now we have got an equation which has a very small value, that is 5. This sum should be equal to 5. Now we can easily write the combinations of these variables such that their sum is equal to 5. So now how many such values exist? So we can break this 5 under this condition. So what can be the combinations? We can see, you start distributing. This is 5. We can say this is 0, 0, 0, 0. So this is one case. Then we can have 4, 1, 0, 0, 0. Similarly, we can have 3, 2. We are just trying to break 5. Then we can have 3, 1, 1, 0, 0. We are just following this condition, that is the numbers are in increasing order and they can be equal also. Similarly, further, if you write 2, 2, 1, we can have 0, 0. Next possibility, you can say this is 2, 1, 1. So this becomes 4, this is 1 and this is 0. And the only last possibility is 0, 1, 1, 1 and 1. So we can say how many such solutions are there. We can say 1, 2, 3, 4, 5, 6, 7. If x1, x2 and x5 have 7 combinations like this, 7 arrangement like this, so obviously n1, n2 and 5 have 7 such arrangement. I'll just explain you one example here, one case here. Take any case here. Let's say if you talk about this, the 7th case. If I say x1 is equal to 1, say this, x1 is equal to 1, x2 is equal to 1, x3 is equal to 1, and 4 and 5. So it will imply what is n1? n1 will be equal to 2, this is 3, 4, 5 and 6. And now you can see what is the sum, n1, n2, n3, n4 and 5, this is equal to 20. And this condition is also satisfied. And similarly you can check all the other. So we can say how many number of such distinct arrangement exist. There are 7 distinct arrangement exist. So answer will be equal to 7. So it was a pretty nice problem, very nicely designed, very less calculated. Only you have to apply logic of basic numbers. Okay. Okay. Thank you for watching the video. Please like, subscribe and share the video for more updates.